Okay, good afternoon, everyone. I'm Kevin Hu. I'm from Supermap International Engineering Department. I'm very glad to be here to share my presentation. As we know, traditional survey is time-consuming and low efficient. With the rapid development of new survey and mapping technologies, drones are widely used for survey. It can produce accurate 3D data more faster. It's a significant trend like the traditional technology will be replaced by the new modern digital survey and mapping technologies. My presentation name is the construction of 3D sense with new fundamental survey and mapping technology. There are a lot of benefits of the new fundamental survey and mapping technologies. First, as the traditional survey is mostly produced the 2D data, and the new one completes the transformation from 2D to 3D. Because it will fully use the new technologies. And as we know, the new survey and mapping products is very abundant, such as Pix4D, Smart 3D, Bentley CC, Street Factory, and Dajiang, Terrier, and so on. So it will produce the 3D data more easy, more faster, and more faster. And the 3D output results will make the 3D real sense, 3D real sense country and 3D real sense city become possible. 李德仁 National Academic gave the definition of 3D real sense. 3D real sense is a digital virtual space that reflects the expression, the national physical sense that human being depends on for survival, production, and life in a real 3D and sequential manner. And the 3D sense is an important part of the construction of the new infrastructure. Provides a unified spatial base for government informatization and intelligence. It's a technical support for the construction of a digital country and a smart society. Significantly, the 3D real sense is upgraded from 2D plan map to 3D stereo sense. And with the range, we can divide it in 3 levels from large to small. The first level is Terrier level. It will use DM, DSM, DOM, and so on to present all the nature in a 3D globe. And the next level is city level. It will use oblique models, point cloud to present a 3D city. And the more detailed one is component level. It will mostly use beam data to render a building, each component of a building, and also the indoor environment. So we can get a result. The volume of real 3D sense, 3D sense data will increase very fast. So I will reports how to construct the construct of 3D scenes with these 5 parts. First, after the practice in the construction of 3D real scenes, we have some understanding and thinking about how to build a 3D real scenes. The first is we think there is a wide and variety data resources for 3D real scenes. And many governments, such as natural resources, water conservancy, and agriculture, and so on, have the requirement for 3D data services and spatial analysis services. So now we can make sure the work contents and the boundary of 3D real scenes. We should provide the spatial data services and the spatial analysis services for the industry business. So it should provide device 3D data and the spatial analysis service to existing platform, and it's also a platform, and it is a base framework that's stable and scalable. We can use the basic framework to develop a new platform for the business applications. The second thinking is we should change the way about schematization. I will introduce about schematization here. I think schematization for GIS means computer we used can recognize the whole spatial object and attribute. Schematization of geoentities, especially intent attributes, need to change the way of thinking from CD. CD is the way we used before. It means a combination of multiple points, lines, and polygons as objects. To GIS thinking, it means a complete geoentity as an object. Then the third thinking is about spatial analysis. For the construction of 3D real scenes, we think spatial analysis are the core capabilities. It builds a bridge for geoentities, geographical scenes, and business needs. And we summarize 3D spatial analysis into 3 levels. The base level is geometric relationship calculate based on 3D entities, such as union, region, adjacent, calculate of selection, etc. And then the second level is spatial analysis based on the whole geography scenes, such as visibility analysis, terrain slope, terrain aspect analysis, and so on. And then the top level is the spatial analysis based on business rules. As we know, all the functions should be used for industry business. So we should, according to the business logic, select the corresponding geoentities and based on the common spatial analysis to build a rule-based base. So now we propose this solution and divide into 4 steps. data collection and production, semantic database construction, semantic 3D real sense data management system, and the base platform for 3D real sense applications. Supermap develop database construction and quality inspection software to construct geoentity database and convert entities data from the original format to standard format, and then to semantic and quality inspection, and then we provide a 3D real sense data management system for the 3D real sense construction, and develop the 3D real sense application platform to provide special data services and special analysis services for business. Now I will introduce them in details. So first, the GeoEntities database construction. GeoEntities we divided into three classes: natural entities, artificial entities, and management entities. To build a semantic GeoEntities database after geometry obtained, then expand attributes. This step is difficult but critical. It's a fusion process. By fusing the data of cross-level, cross-region, cross-system, cross-department, and cross-business, the attributes can be more refined and accurate. About the construction of GeoEntity, we provide ability to access and beautiful existing 3D data. For example, we can link the surface texture to the white model, link the materials to the 3D pipe, and even combine it with the game engine materials to show realistic effect, like the net effect. Here is the process that we provide to link UE texture automatically. First modeling with 2D vector data, and then set up the set texture and the top the top texture fields, and then we can output to the standard exchange format, and then it will be rendered automatically in the game engine such as UE. After the entity geometry obtained, we do the semanticization of the GeoEntities. Semanticization in our software is a process of describe the properties of GeoEntities and the relationship between entities in a standard way, so that computers can understand and process them. This is the database construction standard of GeoEntity data. Next, I will introduce the semantic process of GeoEntity properties. First, based on data standards, we have designed a database. For land natural entities, we have designed basic attributes such as basic, management, natural, and use attributes. For artificial entities, we have designed extended attributes such as population carrying, capacity, and economy carrying capacity, and so on. The next step is the most important I mentioned just now, systematization, which is the process of obtaining the intent attribute. How to obtain the intent attribute? We can use the basic attribute through JS method. Here is a sample. Taking the building geoentities, we design the basic first we design the basic attribute table, management attribute table, population carrying table, and the economy carrying attribute table, and then obtain the basic and the intent attribute through the JS calculate and analysis functions we provide, such as we provide through the multi-source data integration and special location overlay, address matching, and so on to gathering the intent attribute. Then we discuss about the construction of data management system. Years of research and the practice of 3D technology, we have formed reliable 3D technology systems, include 2D and 3D integration model, multi-source 3D data integration, 2D and 3D analysis integration, and multi-terminal render integration. In the morning, my coworker, Mr. Lee, have introduced the 3D technologies in detail. Now I give some outline technology about the 3D real sense construct. First key technology is a complete 2D and 3D data model system. To express the floor space, they are divided into 3 groups: object model, network model, and field model. Based on 3D body model, we can access such as max models, beam data, and perform and use the model to perform a lot of spatial analysis. We can perform 3D spatial analysis using the 3D data, including visibility analysis, skyline analysis, dynamic view shade, shadow ratio analysis. We can also perform 3D spatial analysis, including visible volume, shadow volume, skyline limits volume, openness analysis, and so on. And we also can output the analysis result to suppose another variance industries, such as urban planning. For urban planning, we can combine the business requirement. Here, abundant professional 3D analysis rules are formed for the automatic verification of urban planning and approval in multiple sectors, such as traffic, housing, and construction sectors, and so on. Here is and about the field model. Here is an example. We use voxel grid to express the temporal spatial distribution of the ozone in a city. The second key technology is efficient 3D data processing abilities. The 3D real sense construction is necessary to display variance data in different resolutions, different accuracy, and different types. 3D data more delivers bigger, complex. So with SuperMap, we can access and integrate multi-source 3D data efficiently, like terrain image, oblique photograph, point cloud, and so on. We provide a full solution for 3D data management, from data importing, processing, publishing, to applying with the GPA, Geospatial Processing Automation technology. And the GPA has abundant data processing tools for major 3D data, such as view model, point cloud, terrain, and 3D fields. They can also be customized depending on the business requirement. Here are samples for matching of 3D data, such as beam. We can match beam and DM data. Spatial analysis is widely used in construction and the design industry, such as terrain can adapt to the Anite model. The first picture showed the design of a railway slope protection model. The terrain needs to be adjusted to adapt the model. And we took a lead in compiling the data format for special 3D model tiles. Because we know 3D data is more complex, more big, and the format standard is like for exchange. So with the support of the Ministry of Natural Resources and the National Surveying and Mapping Center, with the participation of the major GIS software companies and the research institute, we developed the data format for special 3D model tiles industry standard, and the standard put into formal use on November 2023. What data format for special 3D model tiles? It provides an open 3D format standard for data sharing. It's used for transformation, exchange, and visualization of massive multi-source 3D data. It supports different terminals, including PC, web, mobile. The CC Bentley supports exporting 3D models to the SIM standard format. And more 3D GIS platform and companies support SIM standard. Then, let's come to the fourth step: construction of 3D real sense platform. First, the visualization is very important. Just now, my co-worker have introduced the view models looks more realistic with the PBR materials, and the beam looks more relaxed with the real-time shadow. The building models looks more realistic with sunlight reflection of glass. And using the high fidelity rendering technology, we could render the wooden texture and the metal pulsing texture in a better manner. This is a web application of Smart City using WebGL platform. The PBR materials we export from the game engine and we can use in our platform directly. And now we can create a more sense of design 3D graphic space, create a more realistic 3D graphic space, and create a cool and high tech sense graphic space. So more visualization, how to merge the business rules in the platform. The spatial analysis is very important. Now I will introduce the ability of spatial analysis. We provide more than 13 3D spatial tools, and other tools allowed to customize. The first video shows a query of 3D spatial relationship, and the second video demonstrates the camera's shooting range. It can list the seats that are within the shooting range accurately. Others are provided by an urban planning approval platform. Okay, let's switch to Shanghai, China. Morning, dusk, and noon. Our partner RainDate shows us a different smart city in Shanghai with the weather effect. Let's get to know the beautiful bond in Shanghai. They combine beam data with game engine. When we enjoy the cool effect, we can also perform a lot of 3D analysis. Okay, the last phase. Supermap actively practice in the construction of China 3D real sense. We have involved more than 10 projects and accumulating rich experience, include province-level projects and city-level. Shandong Province is a large economy and industry province, located in the east coast of China, with a total area of 116,000 square kilometers and a total population of 100 million. In 2023, the 3D Real Sense service platform developed by Shandong Institute of Land Surveying and Mapping based on Supermap platform. The requirements for 3D Real Sense of Shandong are very strict. For example, 0.2 meters high-resolution images and terrains are required for the entire area. It's a big challenge for the data production to solve the problem, and then we should lightweight the mesh data, like terrain data, image data, model data, and so on. It's a big challenge for application platform and to manage mass geoannotated data efficiently. It's a big challenge to fuse multiple types of data in 3D sense. We provide a set of fusion tools such as terrain adjustment and edging, terrain and model matching, Boolean operation, and so on. And this demonstration is Wuhan, a modern riverside city. Wuhan successfully passed the acceptance organized by the Ministry of National Resources in September 2022. Supermap participated in the construction of GeoEntities database, data management system, and application display system. This is the OneMap platform of natural resources survey and evaluation upgrades surveying data from 2D to 3D, and allows to perform 3D spatial analysis like slope and aspect. Surveying the 3D land spatial layout optimized comparison and selection of playing solutions is also an important direction for 3D real sense applications. The 3D real sense platform can display land use plan and agriculture design intuitively. In the meanwhile, analyze the impact on the surrounding environment. Another use is in land space use control, include planning site selection and land use review, design, planning, and so on. 3D real sense applies for economical restoration project from the restoration planning design to the construction processing monitoring and the final exception evaluation, achieve the whole process of 3D supervision. More 3D real sense applications are developing and construction now. As the last I want to give a summary here. The about is the contents of my report. In conjunction, in consultation, the construction of the 3D real sense still face many new challenges. Supermap hopes to give full play to our advantage in GIS in the work, and work with everyone to open up new situations and create new great achievements. I'm very glad to share my report here. Thank you.